Good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So, guys, before we start with the session, can you all please give me a quick confirmation if you all can see my screen and hear me loud and clear as well? Perfect. Thank you for confirmation, everyone. So, my name is Neeraj Kheria, and I've been working in this IT industry for almost 10 years now. So, today we have gathered here for the introduction for the webinar on especially Jenkins tool, right? So, now let's get started. So our main agenda for today's session we'll be discussing on DevOps. Then we'll go ahead and discuss on the concept of CI/CD. That we refer as continuous integration and continuous deployment. And once we have discussed CI/CD, then we'll be discussing on MLP models. And at last, we'll be having a quick hands-on on one of the tools that is mainly used for CI/CD purpose, that is Jenkins, right? So first of all, let's get started on our discussion on what exactly DevOps is, right? So what exactly DevOps is? DevOps is a combination of two departments, of two roles. That is the development and operations, right? So DevOps is basically the complete life cycle. Like just like we had earlier, we had waterfall model. Earlier we had the agile model, right? So earlier we had waterfall, then agile came, and then we have DevOps, right? So there were multiple limitations in following those software development life cycles, right? As a part of agile and waterfall. And now all the drawbacks of those models has been removed when in DevOps, right? So DevOps is, we can say, a continuous life cycle. Continuity is the main USP, the main uniqueness of DevOps, right? So every possible scenario or every phase here is completed and is being taken care of continuously, right? So here we have continuous deployment, continuous development, continuous in testing, continuous integration, continuous deployment, and continuous monitoring, right? So these are different phases. If we talk about different phases of DevOps, then we have continuous building, continuous integration, continuous deployment, and continuous monitoring, right? As a part of continuity in DevOps, right? So first of all, in the planning and coding phase, we use multiple tools, right? Let's say when we are planning on the entire code, when we are trying to build the code, right? And especially when we have multiple team members sitting from different remote places in the globe. For example, let's say when we have a development team sitting in Seattle, the other team is sitting in Hong Kong, the other team is sitting in Singapore, the other team is sitting in Bangalore, right? So here we have multiple teams sitting at remote locations. And obviously, if all the teams are working on the same application, on single application, we all need to share the code among themselves to make sure that the entire application is built and tested properly, right? And for that purpose itself, we have multiple tools which will help us in making sure that we do this in a systematic manner, right? And that's why we have tools like we have Git, we have Subversion, SVN, then we have Jira, right? Where Git is the most popular tool that we use for the continuous development, right? Where we can fetch the code from multiple developers using GitHub, and all of these can be stored as a central repository on the repository method, right? And the main advantage of using Git is it also has version control system. That means if we are using Git, then we can maintain multiple versions of all the changes that we are doing on any file, right? Now, when we say changes, for example, let's say we have a web page and we added a single line or single word in that web page, right? So as soon as we make any changes in any application, in any of the code, then that particular change is saved as new version, right? And that's why we have multiple versions saved for every version created, for every change is done, so that let's say when we want to roll back to a first version, to our initial state, then we can simply roll back to that version as a part of Git, right? And that's why Git is the most popular tool out there, which is used as a main tool, main driving force for continuous development, right? Now, once we have the code, once we maintain all the version of the code, now once the code is complete, we obviously need something to build. We obviously need something to build that code, right? And for building purposes, again have multiple tools. Now in the continuous building phase, we have tools like we have Maven, we have Apache, and we have Gradle. So these tools are basically used for continuous building of the code, right? Now, when we say building of the code, we can say, let's suppose we have created a Java file, right? Now, as you know, Java does not run on its own. We have to create a build out of Java because again, Java requires the entire JVM and we have to build the entire code, right? Only then it can start and then only then it can compile and show the output, right? So for building that code, we have to use these tools as a part of continuous build, right? And since this is continuous, so any changes made here in the code can be fetched and can be built using these tools. And Maven here is the most popular tool for continuous building, right? So although we do have Gradle, we also have Apache, but in terms of popularity and the most widely popular tool, it is Maven as a part of continuous building, right? Now next is we have continuous testing. So for testing, obviously, whenever we are creating any application, obviously we need to test that. And again, here in DevOps, we are not creating the entire application at once. What we have done, we have simply split it. We have simply divided the entire application into smaller packets so that we can test each and every packet, each and every function separately, so that the dependency of checking the entire application in one go, which obviously will require more time and involves more risk, has been lowered down, right? So here in testing phase, we have two main popular tools called Selenium and JUnit, where Selenium is the most popular tool, Selenium is the most popular tool when we are going for testing, for writing the test scripts, right? Now here what we do, we write a test script. That means what kind of test we are trying to create, right? So we also have test ng, we have JUnit, and then we have Selenium that can be used to write those test scripts. All right. Now, once we have the Selenium and JUnit in place, then we simply need a platform. This process itself is called as continuous integration here. Now, when we say continuous integration, we simply mean that whenever we have the test script ready, we obviously need a platform that can fetch those test script and it can deploy those test script on three servers. Basically, when we are testing out, we have three servers to test. We have the testing server, our testing environment, then we have staging environment, and then we have development, or we can say production environment, right? So obviously we need a platform which can continuously fetch the code from Git. It can simply create a build out of it. And again, if we already have scripts ready for testing, then that script can be added to that build, and that can be automatically deployed to these production or testing or staging servers, right? And we have multiple tools which allow us to do that. The most popular tool out there is Jenkins, and we also have tools like we have Hudson, we have Bamboo as well, right? But the most popular tool for continuous integration is Jenkins, where Jenkins has a market share of around 70% in the market. Because of why Jenkins is so much popular, because it has a vast plugin support. That means it supports multiple applications. It supports multiple tools. So even in case we are using Git, Maven, or JUnit, Selenium, so these all can be integrated easily in using on Jenkins using multiple plugins, right? And that's why it is the most widely used tool out there for continuous integration, called as CI process, right? Now, once the entire code has been integrated, then only we move to deployment phase, where we have tools like we have Docker, Vagrant, Puppet, Chef, SaltStack, and Ansible, right? Now, when we say deployment, obviously, once the entire script has been created on the build, right? Obviously, we need a VM. Obviously, we need a VM-like environment, right? And here, what we do here, we have a concept called Dockerization and virtualization, right? We have Docker. So Docker does what? Docker is same like create. Now, when you say creating a Docker image, it's same like creating a VM image, right? So obviously the entire platform, entire code also needs a complete environment to run successfully, right? And Docker and Kubernetes provides that, right? Whereas we have tools like we have Ansible, Chef, Puppet. So these are what? These are configuration management tools. These are called as configuration management tools, which makes sure that the entire build is correct. It is as per the standards and it follows all the guidelines which has been specified, right? And then at the end, we have continuous monitoring, including tools like we have Nagios, we have Stack and Splunk, where Nagios is the most popular tool out there for continuous monitoring. Now, what exactly continuous monitoring is and why we need it? Because let's suppose once we have deployed the entire application, we need a platform to keep a health check on every services, right? And in case of any imminent or any kind of threat, obviously that has to be reported and it has to be fixed as well. All right, threat and any kind of bugs, these things has to be reported and it has to be fixed as well. Now, as we have seen here, these are different stages of DevOps. First of all, we have version control, then we have continuous integration, continuous delivery, and continuous deployment, right? So in version control, we simply make sure that we are maintaining the versions of every changes happening in the code, right? And that's a part of source code management that we have discussed. And Git is the most popular tool out there for version control. As we discussed here, Git is the most popular tool for version control, right? As we discussed, Git is the most popular tool for this process, correct? So here we have Git being the most popular tool for version control. Then in terms of continuous integration, here we simply compile the code, we validate the entire code. That means the entire coding is done properly, and again we again perform multiple unit testing and integration testing, right? And again for now the major popular tools here are Mavens for continuous build. We have Mavens, and then we have discussed we have Jenkins, right, as a most popular tool for continuous integration. We have Mavens, and again we have Jenkins, right? And we also have Selenium for writing test scripts. We have Selenium for writing test scripts here, right? So pardon me for this wonderful calligraphy on the computer. All right, that's what we achieve when we are writing, when we are trying to create calligraphy using mouse, right? All right, so now next we have continuous delivery, right? So again, here we simply deploy the application, right? And we perform multiple unit, or we can say user acceptance test on top of it, right? As a part of continuous testing as well. And this is also part of Selenium that we write the test script on, right? And in terms of continuous deployment, we have tools like we have Docker for containerization here. We have Docker, we have Kubernetes, right? We have Kubernetes, we have Puppet. As a part of configuration management, we have Puppet, right? We have Puppet, we have Ansible as the most popular tool out there for these different processes, right? So that depends. So now these are different versions where just like what we had discussed already. So we have version control, continuous integration, continuous delivery, deployment, and at last we have continuous monitoring. And for monitoring purpose, we had discussed the most popular tool out there is Nagios, where we can use this process to maintain, or we can say to check the health status of the entire application, depending upon the interval that we have chosen. Now, next is let's understand continuous integration, delivery, and deployment in a bit detail. Now, first of all, let's say we understand about what is continuous delivery. So here, now we have something called pipeline as a part of entire development cycle. Now, pipeline refers to different processes involved in development, right? For example, let's say when we commit, that means when we have the entire codes with us, then when we try to integrate it, we build that pipeline, right? We build the code, right? So these are different phases of a pipeline. For example, let's say let's say in the first step itself, we have the code, right? So again, now when we are defining entire pipeline, let's suppose this is the entire pipeline. Let's use a different line for it. Let's suppose here we have an entire pipeline, right? So in pipeline, we can have multiple processes. So here we can refer this as pipeline, as a pipeline. So now what we can do is now we can refer multiple process involved as a pipeline phase. So for example, let's suppose when we have the code committed, again then only it will proceed to second step when we are let's say when we are building the code, right? Once we have built the code, then it will move to next process that is called as, suppose now the code needs to be integrated as well. Now once the code has been integrated, then we can move to monitoring stage, right? So this is what a simple pipeline that we can see here. Now, what exactly is continuous delivery? As we discussed, now continuous delivery is simply a process where the entire code changes are automatically built, right? For example, let's suppose we have the code stored on Git. we have this code stored on Git, right? So as a part of source code repository, we have the entire code that is again built on top of. Once different coders are continuously sending their codes to a central repository, right? Now this entire, now every kind of changes, any kind of different versions being created, these are automatic, these are fetched on regular intervals by the continuous build system, where we have Mavens, where we have Jenkins, right? So again, as a part of this entire pulling system, now once we pull the entire code, then as a part of continuous building, we compile the code, we review the entire code, and then now these are done using Mavens, right? Now this can be done using Mavens here, as we know, Mavens and Gradle as the most popular tool out there. Let me highlight this part. So again, as we discussed, now this entire coding and compiling can be taken care by Mavens or Gradle. Now the source code can be done by using Git, right? Now unit testing, integration tests here, again these can be taken care by Selenium, like we have tool as Selenium, right? And in terms of packaging, we can use tools. In terms of packaging, we can use tools like we have the Docker for containing the entire, right? And then we have to provide multiple UAT, right? We perform multiple user acceptance tests on top of it, right? And once we are done, again, that's why we need to deploy this. That's why we need to deploy this on top of production server. All right. Let's get right back. Now, the main difference between continuous integration, delivery, and deployment, right? So again, what we have done is we have simply performed the complete continuous integration here. So basically what we have is, now in terms of continuous integration, first of all, we build the entire code that we have fetched from a source code management. That is, for example, let's suppose Git. Once we have fetched the entire code, once we have created a build out of it, then we have tested the code validity of, like, if the code is currently validated, then what we have tested, then that's what we test. And then in parts of continuous delivery, we have the entire code. Once it has been built, the entire testing script has been attached, then we deliver it using multiple delivery tools that we have, in terms of performing unit acceptance tests, or we can say user acceptance test, called as UAT, right? And in continuous deployment, what we have, again, it is a combination of continuous build, continuous integration, and deployment on staging, testing, and production servers in production environment. All right. Now, as we discussed, continuous integration, again, it automatically builds for every commit. In delivery, the build, again, automatically build and UAT for every commit that is coming from different source code. Whereas in deployment, again, the entire code is automatically built, and it is now ready for the production for every commit. So it simply pushes the code, and after it has been integrated and tested, it pushes the code to the real world, or we can say production environment, right? That's the main difference between integration, delivery, and continuous deployment itself, right? Now, in here, what we have discussed, now we have the code committed, then we perform the unit testing on top of it. Again, when we deploy it to test environment, it is a part of continuous integration. When we perform the acceptance testing, then it is continuous delivery. And once we deploy the entire application into the production server, then it is a part of continuous deployment altogether. All right. So is continuous integration enough? So again, let's understand this by a simple example here. Let's suppose there are 80 developers working on a single project, right? Now, they may be using continuous integration pipelines to create and to facilitate automatic builds, right? Now, one day, what happened? One day, the entire system, now all the developers, they wanted to deploy the last build that had been passed, the unit test into a testing environment, right? However, the entire system did not work, right? So theoretically it should work, but again practically it didn't work, right? So what happened here? So again, once we have the entire automatic build from the continuous pipeline, then once the entire the test reports came in, now they want to deploy this to the real environment, or we can say deploy this to the test servers. And again, this deployment was failed. All right. Now, why exactly it failed and why exactly we need continuous delivery? So Now, basically, one of the developers here, they simply tried the application on their own machine itself, right? And again, the application didn't work there either. So how it could work in real world, or we can say production environment, right? And again, now for finding the issue here, they came back, they went back a few versions that they have made changes into the entire code. All right. Now, what they found in now here in pipeline, suppose let's say here we have multiple different pipelines, 86, 85, and 88. Now they found that the code actually run, the code was actually fine in the suppose in 85th pipeline. That means in 85th revision, in version number 85, the entire code was functional, because again, as you can see from the log, the entire code was completely functional in 85th pipeline, but after 85th, it stopped working. It stopped working because it didn't pass the UAT in 86th, and in 88, we didn't pass the acceptance test, right? So again, that's a major drawback in terms of development, because again, now it came back, right? So first of all, it failed the UAT, and then it failed the acceptance level itself, right? So here are the main, so again, if we are trying to deploy this, again, it won't work at all, right? Because here we have to again go back and use the same and fix this problem and see what was working in pipeline 85 and how we can replicate this to pipeline 88, right? Again, this is also done using this can be done using VCS, because again, using VCS itself, we can know what kind of version we had maintained, and then we can compare the earlier version with the current version to see what kind of errors we are making, right? And that's a major advantage of using VCS as a part of DevOps. All right. Next is we had tools for CI and CD. As we discussed, the most popular tool out there is Jenkins, but we also have Buildboard, we also have Bamboo and Travis, right? But in terms of the most popularity was and the market share and most popular tool out there is still with Jenkins, right? So Jenkins, as we know, is easily integrated. It is supported by multiple plugins that we can use to integrate multiple different functionalities into Jenkins, right? And that's why it is much praised for having the support for these many plugins out there. All right. So now let's go ahead and take a look at Jenkins as a part of hands-on. So what exactly Jenkins is and how we can get started on creating Jenkins or on using Jenkins here, right? So Jenkins, as we had discussed, it's a completely an open source tool that is written in Java, right? And again, we have Jenkins master slave where we can use these slaves, right, to provide the environment itself. So here we have one master where it can share all the workload to different slaves, and slaves, they provide a simple, or can say a single architecture or complete perfect environment in which the entire code needs to be run. All right. Now, next is as a part of Jenkins, we have multiple support for all the plugins out there. Like for example, for testing, we have JUnit, we have Selenium. For report generation, we have HTML Publisher. For notification services, we have the inbuilt notification plugin. For deployment, we have deployment plugins available. And for compilation, we have Mavens that we have discussed already, right? Now, let's go ahead and see how we can get started on top of using Jenkins. Let's go ahead and see that. And as an example here, what we can see here as a part of example here, we can see that we have, first of all, in when we create any projects, what we do, we simply fetch the code from Git, then we compile it, then we conduct multiple unit testing on top of it. Once the unit testing has been done, then out of those multiple, now unit testing is done on multiple small units, right? Like we have small packets. And once the entire, all the packets has been tested, then we combine the entire package and then we deploy it on the servers, on the environments as a part of Jenkins complete workflow. All right, so now let's go ahead and see a quick hands-on on top of Jenkins, right? Let's look at that. Now for using Jenkins, okay, let me show you the window here, just a moment. So now once we install, now for installing Jenkins, what we can do, we can simply go ahead and use this. We can simply search for download Jenkins. So depending upon our system, guys, whether we are using Mac, we are using Linux servers, we are using Ubuntu images, we are using Windows, we can choose our system and then get started into downloading it. All right. Now, once we click on Windows, again, this will simply download, and then we can simply install Jenkins into our system, right? Now, once Jenkins has been installed successfully, then we can get started on using Jenkins, right? And to get started on using Jenkins now we simply have to open up our browser, and here we have to type in as local host colon, and the port should be 8080. It should be 8080, right? So by default, Jenkins will be installed on a local host machine at port 8080, right? So in order to start using Jenkins, we simply have to type in localhost colon 8080 into our browser, and then we'll be looking at the login screen. And now the username and password will be the same that we will be using at the time of installation, right? So whatever we set at the time of installation, the same username and password we have to enter here. So let's enter our username and password. And once we have entered the right credentials, the correct credentials, then we can see now this is being opened up, right? So now this list, now this particular is, now this is an entire dashboard for Jenkins that we are looking at. All right. So this is the entire platform that we are looking at. Now this here, as you can see, this contains the list of all the projects or all the projects that we have currently available in our Jenkins system. And here we can see the status of these different projects, right? The name, and again, when it was last successful, right? And when we can get started on creating a new project, right? Now, to start creating a new project on top of Jenkins, what we have to do is we simply have to click on new item, right? A new item itself. And now when we click on new item here, we have to choose between different project that we can see here. So first of all, we have freestyle. That means here there is no dependency. We can choose what kind of project that we are creating. We can simply customize this as per a requirement depending upon different services and different process that is involved in this particular project, right? Then we have Maven's project. Then we have pipeline, where we can define the entire pipeline in a sequential manner, right? Then here we can use GitHub as well. Suppose let's say we have a code saved on GitHub, we can also create a GitHub project. We can do that. All right. So depending upon a requirement, we can choose the project type, and then we can get started on using Jenkins. So first of all, we have to click on freestyle project. So we can give this project any name. For example, let's give this Edureka 1919. We can give this any name. Suppose Edureka 1919. It can be any name. Click on OK. All right. So now once we click on create a project, here we have to describe the project. We give a short description to the project. So here we can name anything. Suppose this is sample project that we are trying to create, right? Now here we can choose. Okay, this is a GitHub project, or again, if you have multiple projects already deployed on GitHub, then we can specify the URL here, or we can keep it as it is, right? Next here, we have to define the source code management, because again, since this is a project, we also need to specify the source code, right? From where this Jenkins will be fetching the source code, right? So for example, let's suppose we have the project deployed on Git, right? And then here we have to mention the Git, our project URL on GitHub, right? For example, let's say we open up our GitHub and we specify the GitHub URL repository, right? So here we can copy the link for our GitHub repository that we have currently active. And now we can come back. Now, since this is Git, we have to mention at the end .git as well, right? And then we have to mention the credentials as well. That means what is the credential that we need in order to access this account, right? So here we can add any credentials that we have already added. So here we can go add, right? Because whenever we are trying to, again, it won't happen that, okay, we can start working on any project available publicly, right? So we have to mention the credentials as well, right? And now once we have specified the repository URL here, then we again scroll down, and then we can define the build trigger property. That means, again, we want this entire project to be built remotely, or we want this to be schedule at regular intervals, we can do that, right? Now, once we have then we have to choose the build environment. That means we want to now what we exactly want, what kind of build environment we want to have, right? So we want to use Ant, like we have Apache Ant. We want to use with the Apache Ant for building purposes, right? Or we want to use Gradle for it for building the scans. Or if we don't want to use any of these, we can keep it blank as of now. And then we have to define build step as well. That means once the entire build has been completed, then what should happen? Then we can choose if we want to execute a shell command. We want to invoke Gradle script. Again, if we have something something already deployed in Gradle, then we can attach that Gradle script to our project, right? Then we can do that, right? And at last, we have to choose the post build action. That means once the entire build has been completed, then again, we should be, so suppose here we can choose to be notified. That means if we choose email notification here, we can choose, okay, on which email we want to be notified here. So we can simply enter our email. For example, let's say we have xyz@example.com as an email. Then we can choose to be notified, right? So let us put the email here. Now, once we save it, this entire project has now been saved. Thank you so much. Take care. Bye-bye.